Hi, this is Margo. This is Friday, June the 8th, 2018, and today I'm going to do an update on sulfur dioxide levels around the world, methane levels around the world, and carbon dioxide levels around the world, and then we're going to look at climate reanalyzer briefly. So, I've got the global view of the sulfur dioxide levels up, and the areas I'm going to be focusing on are still Hawaii, because that's still got a lot of sulfur dioxide coming up, as you can see from the ongoing activity there, volcanic activity. Guatemala over here, where the volcano exploded on, it was June the 5th UTC time. It was June the 4th in my time, so you have to calculate depending on your time zone, but I wanted to get this update recorded while the data was still available. And then this area here, that in the videos before I thought that this was Costa Rica, but Costa Rica is further down here. And we're going to look at a world map in a minute and see where these countries are. There's actually an active volcano here. This is in Mexico. And I've already got, well, I had that up. This is what happens when I get started. They start crashing everything for me. There is an active volcano, Volcan Arizaba. And that's what you're seeing here. And there are different kinds of volcanoes. There are ones that are active but that don't blow up, but that just continuously release these toxic gases of sulfur dioxide, carbon dioxide, and methane, and a whole bunch of other toxic gases. And they are constantly released into the atmosphere. And then there are volcanoes that just explode and then kind of go down. And the one in Guatemala was one of the exploding ones. And when we run this movie, you're going to see that the amount of sulfur dioxide that was released into the atmosphere from the Guatemala volcano was not nearly as much as what's consistently coming out of this volcano in Mexico and what's still coming out of Hawaii. So I think you'll find this interesting. So let's run the movie. Here it goes. And you can see there's the explosion. And that was on June the 5th. And then you can see it dissipating. This is real data that's been compiled in the CAMS system. This is the Copernicus atmosphere operating, or this is the CAMS website that we're on, Copernicus atmosphere monitoring system. And then you don't see it explode. This is actual data until the forecast. Now we're into the forecast period on June the 9th. So they're forecasting from the data that was collected what else might happen through the end of the forecast period. But up through the current date, this is the real data. So let's go back to the beginning of this period, where it's actual data starting on June the 4th UTC time. And we're going to run the movie again, and I'm going to pause it right when Guatemala blows up. There, you see, it's right down there, and that's at 3 UTC time on June the 5th. And then you can inch it forward. It goes by every 3 hours. See, it's still in the atmosphere. and now it starts to dissipate. So within a 24-hour period, it was dissipating because it didn't continuously explode. And so what I find surprising about this is that when it did explode, when the most that was in the atmosphere was not a huge big red plume like what you're getting off of Hawaii, and it's not like this constant red coming out of Mexico. It's more of an orangey color, and it's dissipating pretty quickly. And so I found that interesting. So let's start at the beginning of the forecast period and run that again so that you can really, now watch here. Watch right where the hand is. Boom. See, there it is. And that was the Guatemala volcano. And then it's dispersing into the sulfates and mixing into the atmosphere. Now, look up here at how the sulfur dioxide is dispersing over all of North America here, especially the United States. But you saw when you run the movie, if you look here and it comes over and it's really dispersing over the whole United States, and that's in a gold, like that's 2 parts per million. And every little bit, you know, that is added to the atmosphere, it just keeps accumulating for problems later. And then you've got this going off in Alaska. I don't know what that is. I haven't really looked at that. Then you've still got activity down here in Chile. What we do see in this period is Brazil has calmed down. Remember, there was that big red area in Brazil last time. And up here in Siberia, that's calmed down. There's no big sulfur dioxide release in Siberia. See, you can see it coming from Hawaii across the Pacific Ocean and then coming and dispersing over the United States. And you can also see that the red that had accumulated over the Arctic had dispersed, and now it's not red anymore as far as sulfur dioxide goes. So I thought all of that was interesting. So we'll stop that movie. And now let's go to methane levels around the world. Remember last time I did a show about the methane spike, how the methane had spiked earlier that week, and when it spiked, I can change this to surface level. When it spiked, it was like really orangey all the way up over the Arctic, and you can see that that's dispersing. But if you'll look back at some of my earlier methane updates, down here at the southern hemisphere we had more blue, and now it's gone more towards blue-green, more towards 1780 and 1800 parts per billion on methane as a constant now. And we had green, it was mainly green up to the Arctic, but look, it's orangey. And so the overall methane levels have really stayed high across the whole northern hemisphere. They've really stayed high. Now, what I find of interest this week is this area up in northern Siberia. There's a lot of methane being released and coming over the Arctic Ocean, and it's gathering and circling around in the Arctic, and also over England and off the coast of England, and so this is the area I'd really like to look at today, and we'll look at a polar view in a minute. So we're going to load this movie. This is actual data back to June the 4th. And so let's see what's going on methane wise. There's a lot being released in Alaska. Look at England. And look at this red cloud. It's just coming up and it's circling around in the Arctic. And as the methane is being released, it will heat up the atmosphere and the air. As it gets hotter, then of course all that sea ice will be melting faster. This is Novaya Zemlya, and you can see all the methane here off the coast of England in the North Atlantic, and off of Norway. And of course it's coming up off the east coast of the United States. And then we got melting permafrost across Canada, across the Siberia. And you can see that parts of the world, the methane levels have decreased this week. You can see that Africa, this area in the Congo in Africa, is not releasing as much methane as it has in the past. And South America looks like it's releasing less. So it could be, as we're heading into summer, the Earth is still moving on its axis and tilting. The North Pole is tilting more towards the sun, and so the South Pole is tilting away from it, and so they're going into their cooler season there. Let's pull the map over and see what's going on in Australia. You can see there's not much methane being released in Australia, just kind of around the edges there, because you really need more humid conditions. If it's being released over land, you need humid conditions, and most of Australia is pretty dry. But it can be released from fracking, it can be released from just industrialized civilization. I did a whole video, my first methane video, I talked about where different sources of methane. Of course, we still got a lot over India and over China and Asia and this area here in the Middle East. That's a big oil production area. So that's what you've got going on worldwide for methane. You've got, now let's see, it's being released down here near Guatemala. Of course, that's a humid area. Let's run the movie again and watch. This is where the volcano went off. Now it fluctuates. The methane readings go down at nighttime and up in the daytime when it heats up. That's why it seems like they go away. They're not really going away. They're still there. Okay, so let's go to your polar view. Here's methane, and our latest data just came in from Wednesday the 6th, and then we can run the movie and run the forecast to see what cams will be forecasting for the Arctic for the next 5 days from June the 6th. Remember, this is UTC time. And this is at surface level. Okay. See, this movie runs faster than the other one. You can see how the whole Arctic is still orange in color, and in the movies before that methane spike it was more chartreuse. So the overall levels of methane are still a lot higher in the atmosphere. They haven't gone away. And here it is off the coast of England in the North Atlantic. So let's zoom in on the Arctic here and run it, since this is of very high concern with the melting sea ice. And I think, you know, if we just are kept up to date with these levels and really see how they're changing from week to week and how everything is escalating, it will help us be better prepared for things as they happen. Because a lot of climate scientists are predicting that this summer will be the ice-free Arctic. And even if it isn't totally ice-free, it's going to be enough ice has melted that we'll have much more methane being released. Look at that. See, it's just swirling around. And see how it's coming all the way up to exactly the North Pole. And see, it's really red. See, it's staying red over by Novaya Zemlya. Now it's running again. And then this area over here, this is the East Siberia ice shelf, where they're so concerned about the big methane bomb. And for those of you who heard my interview with Guy McPherson, one of the questions was, when do you think the methane bomb will be released? And he said that he was shocked that it hadn't been released already, which implies it could happen anytime. Anytime. Any day now. Any moment now. So we're just watching everything just click down. Tick down. It's just it's like the clock just ticking down on a bomb. Okay, I'm going to go back to catalog, and now we're going to look at carbon dioxide worldwide. This is at total column. So that's the measurement from the ground up through the atmosphere. and this is measured in parts per million. And you can see the chart down here. This gold color, orangey gold, is 410 parts per million. The red is 411, and then as it goes into darker shades of red, it just gets higher and higher. This dark red, like that dark red right there, that, according to this graph, is 415 parts per million, and then where it goes black, that's 600 parts per million. So this is, we're going to run the movie back from June the 4th, and you'll see that the Arctic is totally engulfed in not the red, but the darker red. So it's gathering. And carbon dioxide is also released from volcanoes. Okay, it's loading the movie. It's kind of stopped. I don't know why that is. Let's get it going. Okay, here we go. It just takes a little bit for everything to load. There it goes. It's still lagging. Could be because I have so many windows up. I don't know. Oh, here we go. Now it's going. Look at this dark area. I'm thinking that's as a result of what's come off of Hawaii. And it's come across the ocean and it's spreading out over North America, and see how it's coming across the Atlantic there. There are lots of dark areas across Africa and across Saudi Arabia, and India is practically covered up. And look at this dark area in the Pacific Ocean here. This is from the Hawaii volcanic plume. See, it starts over there on the right. It starts over. So now it's into the forecast period. Let's go back to the beginning and run it again. So basically the planet is suffocating. If you think of these layers of these toxic gases and things in the atmosphere, they're just moving around from place to place and swirling and moving, and then it rains and then comes down in the rain and then it goes back up, and it's just, you know, no wonder all the trees are dying and the fish are dying, and, you know, it's just a toxic world. It's sad, but it's just turned into a toxic world. And you can actually see, if you click on these other levels, you can see the concentration of these different, greenhouse gases at different levels in the atmosphere. For instance, like the carbon dioxide at surface, that doesn't look too bad considering, I mean, that looks more like methane, like the methane map. But that's at the surface level. But then if you go to 850 HPA, that's above the surface. That's about 3 kilometers, I'm thinking, between 2 and 3 kilometers above the surface. 850. Now look, let this see. So it becomes more accumulated at different levels in the atmosphere. That looks like the apocalypse. See, that's higher in the atmosphere. One of my YouTube commenters was gracious enough to explain HPA to me. And so the lower the number on the HPA, the higher it is in the atmosphere. I didn't know that because I'm not a scientist. I didn't study this before. I studied music when I was in college. I have a master's degree in classical piano. I was going to be a concert pianist. And here it is. This is at 500 HPA, and that's at 5.5 kilometers up. So see, it's even worse, more accumulated at that level in the atmosphere than lower down. So this is why the climate scientists are screaming about carbon dioxide, because this hangs around. It doesn't go away. It doesn't go away. That black. The black is 459 parts per million. So it's all, you know, it's everything in between. See, and it's even in the Antarctic, like really high. The red, that's 406 to 407, 408 parts per million, even in the Antarctic. And why you have this little area right here that's so much less, I don't know. I can't answer that. And then, you know, a few little pockets here and there that's so much less. I can't answer that. Then at 300 HPA, that's even higher in the atmosphere. See, it's still really concentrated. And at 50 HPA, that's where it starts really dispersing, because you're really up there. Like 10 HPA is 31 kilometers, so it's not quite 31 kilometers at 50 HPA. So there you have it. So let's go back to total column of carbon dioxide. That doesn't look the same. Anyway. So that's how things are looking around the world. It's not looking good. It is not looking good at all. especially when you got all this methane coming up from Siberia and coming up into the Arctic Ocean like that. That arc, that is scary to me. So let's look at Climate Reanalyzer and we'll wrap this up. Here's Climate Reanalyzer. Here's your home page. So let's look at today's weather map and the temperatures around the world. This is in centigrade. You've got your chart over here on the right, and you've got your world view here, and you can see in the Arctic, like the green where it goes into yellow, like the chartreuse, that's at 10 degrees Celsius. The blue is 0. Like this is 0. This is frozen. I mean, this area is still frozen, but the temperatures, with it being so warm, all this frozen area is going to start melting even faster. Because see, this is like the North Pole, and it's above 0. It's above freezing at the North Pole right now. So, like 10 degrees Celsius, I've got my cheat sheet here, is 50 degrees Fahrenheit. Like that color there, that's 50 degrees there. 50 degrees over the East Siberia ice shelf. This is where, oh, and here is where all that methane's coming up and coming across and making that arc. And that's probably why it's warmer up there, so much warmer. You see it's going up around Greenland, and see it's all, like there's no ice in the Bering Strait anymore. Not with summer coming on. So let's go to temperature anomalies. This is how much hotter it is than normal. And it's above 2C more than normal up here. Very hot up there compared to what it should be. And precipitable water. You can see what's happening. With your levels there. Snow depths. Uh-oh. Snow depth. This is in centimeters. cm. That's not looking good. Sea ice and snow cover. Wow. Look at the difference since the last time I showed this map. This was not blue here. That was still white. So the sea ice has melted there in the Arctic. It is totally melted. And see how the blue is coming in? That's melted. That's melted. And that's where that methane is coming up and around, up and around. And see how much further it's melted in around Alaska. Then the northern part of Canada, it's melted. And look, Greenland, it's almost all melted around a lot of Greenland there. I'm shocked. I mean, I haven't looked at this in a couple of days. So it's changed just a lot in the last couple of days. Sea surface temperatures. Centigrade, Thursday, June 7th. So that's from yesterday. They haven't updated, but that's okay. See, down here is 0, and then when it starts going into a color, it starts going up. And that purple is 5 degrees centigrade, or Celsius. So 5 degrees Celsius is 41 degrees Fahrenheit. So the sea all around Greenland and all up here where that sea ice is melting, 41 degrees Fahrenheit, 5 degrees Celsius. So it's going to be melting. See, it's already melted here. See? Off the coast of Siberia. It's already 41 degrees up there. Or close to it. It might not be quite that much, but it's purple. It's not white where it should be 0. Sea surface temperature anomaly. This shows the difference in temperature by Celsius of what it should be, and you can see this is where that methane was curling around all up here, and see it's 2 to 3 degrees warmer than it should be. And then here, where it's already melted, it's warmer than it should be. So there you go. So my name is Margo. My website is Margo's Healing Corner. I think time is short. And I suggest everyone get their spiritual house in order, whatever that means. Until next time, take care. God bless, and goodbye.